We're continuing on talking about the idea of kinematics and how that pertains to motion. We're going to be looking more specifically at motion that has a changing speed. Okay. It could also be changing velocity. It could also be a changing velocity. Changing speeds or changing velocity. Being as that the word speed and word velocity are very interchangeable. Okay? Now, our understanding of motion should come at no surprise, is nothing really truly new. But when we come down to the topics of what did we know or what did we think about motion was, well, it comes down to is where did we find out a lot of things? Well, ancient Greece, those people they did a lot of thinking. And why are they accredited with a lot of stuff is because they did a lot of thinking, but they get accredited for it because it's written down. Okay? There's documentation that there is. Now, Aristotle tells that there are two types of motion: natural motion and violent motion. Natural motion, anything straight up or down. Things that occurred in nature would be natural. Smoke rising out of a fire is a natural occurrence. That was considered to be a natural motion. Boulders being on the ground, things finding their resting place, so to speak, are a way of nature. It is what nature intended, maybe is where that phrase comes from. It is what nature intended. It is what nature intended. That natural motion. Then anything that is moved outside of way nature intended is considered to be violent. Pushing a tree over is considered to be a violent motion. Anything that is a result of a push or a pull. You pushing on something. Swinging a hammer would be considered a violent motion. And especially even if you're just hitting it the nail on the head. It is a violent motion. Something that is in its natural way and is moved outside of its natural way. Something moved beyond the way nature intended is considered to be a violent motion. To move something against nature it was thought that a force was responsible for an object to move against its nature. And some of that is because we didn't truly understand all of the forces that are involved in our everyday life. Now, the state of object was considered to be one of rest until they were pushed or pulled, until they were moving towards their resting place. You can get really philosophical there too if you want. You're just moving through life till you find your resting place. Isn't that a little deep thought? And if you don't move in life, you're not going to find your resting place. Also, only large forces can move objects. And therefore, because the Earth is so large, any force, there is no force imaginable to move the Earth. Therefore, the Earth doesn't move. Well, that's just wrong. Copernicus says that the Earth moved around the sun. What bothered a lot of people, and they said, well, the sun is small, look at it. It's small. Compared to this, we can't even see the end of this. This is Earth. We can't see the end of it. It's obviously bigger than that sun or that moon. So obviously, they go around us. They were not maybe the most enlightened people. However, Copernicus eventually proves them all wrong and says, no, we live in a heliocentric solar system. The Earth is not the center of the solar system. It is not the center of the universe. There is a much bigger world out there. Very hard to sometimes come to terms with. Especially when you have these things that are moving with forces that we can't see. And even the forces that we can't see can be as simple as dropping a piece of paper. Why does it fall? Falls because of gravity. You can't see gravity. And when we deal with these things that we can't see, it's very hard to understand. That's why many students take physics as opposed to maybe chemistry. In physics, most of the stuff that we talk about, you can see. When we talk about projectile motion, I can throw things at you in the classroom, and we know that things move through the air at a certain angle, because if I threw it at you straight, it's not going to hit you in the head while you're sleeping. It's going to go either below your desk or above you. And it's something that's affecting that on why it drops. Gravity, we can't see it, but it's there. Why does the Earth move around the sun? Gravity. But it's a different kind of gravity, but yet the same gravity as why an object falls to the ground. They're considered to be big G and little g. Big G, celestial objects. Big objects. Little g, objects falling on the ground. Now, Galileo was your big scientist that when everyone was yelling at Copernicus that he was wrong, Galileo says, no. He was right. And so, as he started to give us the physics and the science to back up Copernicus, Galileo, not a popular person in some circles. They didn't like him. Why? Because the people that were in charge at the time said, no, you're wrong, Galileo. He goes, no, I'm right. Here's why. Look at all this data. Here's all this science that backs me up. And they said, oh, no, we don't like that. We'll just go stick you somewhere where we don't have to listen and see you anymore. Which isn't really good. Don't worry, he got a lot of better science even happening, and he found his way out of that. However, those are not good things to have. Our understanding of the world changes. It might not always be easy, but it changes. Copernicus was suggesting a very big change for people. We are no longer the center of the solar system, and we are not the center of the universe. That's a big problem for a lot of people. Galileo coming back and saying, yeah, he's right. Did not make him a popular man with the leaders of the world at the time. But now we have time to look back and go, man, were those people crazy. How did they not believe that person? Had all this science to back them up. Well, there will be a time in human history that they will look back at us and probably say the same thing. Just as we even look back 30, 40 years ago in history and go, why were they thinking? That's so backwards. Why would you put lead in paint? It's a terrible idea. Kids can eat it. It causes neurological diseases. Why would that even be a thing? Well, science. Or better yet, why do we do asbestos abandonment? Because it's not good to breathe in. It's a great flame retardant. But it's not good to breathe in. Find that out after the fact and go, oh, yeah, not good. Especially if you're an electrician or a plumber trying to do anything that has asbestos around it. And you're not taking the proper safety precautions, which they did early in the 70s and 80s. They had no idea that it was bad, and then all of a sudden people started getting sick from it. So it becomes a reactive thing. Instead, we need to think and listen. And maybe these people aren't crazy that are the scientists telling us things. Now, according to Galileo, testing his idea by rolling balls down a plane, he tilted them at different angles. A ball rolling down an inclined plane speeds up. Most of us think about this and go, duh, really? But you have to understand, simple things have, even things that we take for granted, the understanding and the stuff that we take for granted now, had to be discovered by somebody. The fact that you can walk into a room and the lights go on, either by the fact that you have an infrared sensor or you actually flip the switch. Someone had to figure that out. So yes, objects rolling down an inclined plane speed up. Objects rolling up an inclined plane slow down. Most of you could experience this by just trying to walk down a hill. You naturally speed up. Why? Just way of nature. Go up the hill. You slow down. It's tough walking up hills. It's not fun. When there's no slope, speed doesn't change much. Nice smooth plane. Everything just rolling as it should be. So let's define friction. Friction is a force. It's a force that is there and acts between materials that touch as they move past each other. It is the irregularities in the surface of the objects in which they are touching. Even very smooth surfaces have irregularities. If something has been, say, chrome plated, a lot of the irregularities in the metal are filled with chrome to try and make a very smooth surface. And it looks very, very smooth. And especially if something is nice chrome shined on it, it almost acts like a mirror. But even that has very small irregularities on it. In the lab, we can try to limit friction as much as we possibly can. But it's not going to be perfect. The carts that I drive or move around in the lab may or may not always have the best wheels on them. Why? Well, it's just because they're just usually bolts that are put through that are smooth and you're using plastic. You're like, well, that should be smooth too. It's irregularities that we can't see that are there that make this difficult. A glass marble is going to still have irregularities. So we can't get rid of friction, and this is why sometimes the labs that we do in the classroom don't always work. Because you can't get rid of friction. It's always there. And it messes with us. In some cases, we can take it into account. And when we do, We really are pushing our limits of understanding. But there are some times that we will try to say, ignore friction, because it becomes too complicated to understand what's going on. There's too many variables. Another big term is Galileo says that the tendency of a body moving is it will want to stay moving. Meaning an object does not want to change its state of motion. I always like to use this as the example. When you're in your bed, you don't want to get out. And most people would agree with that. You are at rest. Getting you out of bed takes a lot of work sometimes. You are resisting your change in motion. And some people understand that once an object is moving, it's very hard to get them to stop. If you have ever driven down the road with a large vehicle that is loaded up, I remember back when I was moving, some pavers in the back of my pickup. I had to take into account that my pickup now had more mass when it came to speeding up, because it is going to resist that change in motion, going from a stop to a go. But once I got going, I had to take into account the longer it's going to take me to stop, because it's going to resist that change in motion. And you have to take that into account as you're driving around. And it doesn't take much to all of a sudden change things on how that resistance to change is. That's why vehicles that are very tall, they are also resisting change. That's why they have a high case of rollover. It's their inability to make that change easy and quickly. So, something to think about. As we end, a ball is rolled across a counter and slowly comes to a stop. How would Aristotle interpret that? How would Galileo interpret that? How would you interpret that motion?